So if we can go to the next talk, which is cloud native formats for planet scale vector tilesets from Markus Tremmel. Markus, I see you're here online.
Now you should see my presentation. Huh?
We see it. We see the presenter screen with the notes. So I don't know if you want to share.
With the note, then I change. Okay, so now it should be fine. Now.
Yeah, no, it's fine. Perfect.
Okay, so yeah, hello everybody. My name is Markus Tremmel, and I work at a company called Rohde & Schwarz. And today I want to talk about why, in general, there's a need for a cloud-optimized tile archive for global scale tileset. And I also want to give you a short overview of how such a tileset archive basically could look like, based on a case study I worked during the last few months, and I already successfully used in some projects with significantly reducing the storing costs. Okay, so if you want to deploy a global scale tileset in a cloud-native environment with current technologies or tools without the use of a cloud-optimized tile archive format, you probably have two major options. The first option is you could use a backend with a database where the tiles are stored, and also then you can use a tile server for providing the tiles to a map client. Then there's also a second option. You could also directly host the map tiles on an object storage. The problem is that both options have major drawbacks. In my opinion, in general, they are both unnecessarily expensive, especially if you're hosting large amounts of tiles. So if you're hosting global scale tilesets. So we have faced these problems in our projects and in our products, and because of this, I started to work on a solution which I call a cloud-optimized tile archive for planet-scale tilesets, and so I would call it something like an MB-Tiles or a geo package for the cloud. And the archive format is very similar to other cloud-native formats. So there is a data section where the actual tiles are stored. For example, there can be raster or vector tiles with focus especially on vector tiles. And then there, in addition to the data section, there is a metadata document which describes the structure and the layout of the archive format. And then there's also an index which is referencing the tiles or the position or the offset of the tiles in the data section. For describing the content and the structure of the tile archive, there's already a good standard in work, which is called the two-dimensional tile matrix set and tileset metadata specification of the OGC, which is currently a draft, but which also fits very well for describing cloud-native tile archives. And this standard has to be extended with additional properties about the index layout. For example, if they on which space filling curves they are, or which space filling curves is used. And then the most time I spent on designing the index, and I ended up with a workflow like the following. So if you open up the map and then there a compressed tile pyramid is loaded with the initial fetch along with the header. At global scale tileset, we are talking about zoom level 0 to 7. And then when the user zooms more into the map, it turns out that compressed tile pyramids are not that effective for lazy loading portions of the index. So I switched to a different approach, which I call index fragments. And index fragments are simply an aggregation of index records with a default of 4096 index records aggregated together. And then for efficiency, these index fragments are ordered on a space filling curve, for example, Hilbert or in Z order. And with this approach, most of the time, only one additional prefetch per zoom level is needed before accessing the actual map tiles for the current viewport of the map. And I would say this is really, or even not all, noticeable for regarding the user experience. So if you're hosting a COMTiles archive on a CDN, we're talking about in a medium internet connection about 20 to 30 milliseconds for fetching that fragment. And because of why the tiles are ordered on a space filling curve, you could also then batch together the tile request to, on the one hand, to improve the performance. This works for HTTP1 requests, but in particular to reduce the storage cost, or to more precise, the transfer cost. And this can reduce the number of tile requests by about 90% if you use that batching feature. Okay, and then one final thought. I think there are a lot of standards out there in the OGC which are standardizing stuff like with tiles. For example, there's WMTS or Geo package, which evolved from PMTiles. And there is also the new API standard, which is called the OGC Tiles API standard out. But I think there is still missing a standard for cloud optimized tile archives. There are a lot of cloud optimized formats out there. I think the most used is probably PMTiles. And also COMTiles, which I showed you today, both show that this is working and can reduce the cost of hosting tiles in the cloud. And because of this, I hope there will be some future work on, or a working group on working on this stuff for having a standard in the future. Yeah, thanks.
Thank you, Markus, for your presentation, and also for keeping the time. So